Good morning. My name is Rachel Jordan, and I'm a science educator with the Exploratorium. I'm here today to talk to you about a subtle shift a teacher and I made in a fourth grade classroom in a lesson about magnetism. A subtle shift is a small change in a lesson, in this case to add the cross-cutting concept of cause and effect relationships. The curriculum the teacher and I were using was developed prior to the Next Generation Science Standards, or NGSS, but this change shifted that curriculum more towards NGSS. This is an example of a subtle shift in response to how a lesson went. The shift was to add a mini lesson on the cross-cutting concept of cause and effect, and to apply this thinking to helping students analyze data. This particular lesson actually had two shifts. In this video, I'm going to focus on the cross-cutting concept shift, but the shifted lesson also included the science practice of modeling, which I'll discuss in a separate video. I'll explain the original lesson in a little bit more detail in a moment. I just want to set the context for this shift. Just a moment. Which was that the students were having trouble with the making meaning part of the lesson. They could not analyze and interpret this graph, which is showing that the greater the distance between two magnets, the weaker the force between them. This is an example of a kind of shift that was made in response to a lesson. It was not pre-planned as part of the original lesson. We thought that using the cross-cutting concept of cause and effect relationships might help the students make sense of their data. The students had explored magnets, seen that they attract and repel, and seen them interact with other materials. They saw that there was a push or a pull to the magnet. This lesson is supposed to help them see that there is a strength to that push or pull that gets weaker with distance. And so how this lesson worked was there is an equal arm balance with two plastic cups, one on either side. On one side, the plastic cup had a round magnet in the bottom of the cup. And then on the bottom of the equal arm balance was a magnet glued to a post. And those two magnets were attracting each other. The students would put washers in the cup on the other side of the equal arm balance until the two magnets separated and the force broke. With each subsequent trial, they would put a small plastic spacer in between the magnet on a post and the magnet in the cup to increase the distance between those two magnets. And so the students were supposed to see that as they recorded the number of washers it took to break the force between two magnets, that as the distance between the magnets increased, the amount of force decreased to break the force attraction between the two. Each group got a set of 6 sticky dots in a different color. They were supposed to plot their data on a class chart with their sticky dots so that the teacher could discuss the data with the class as a whole. The lesson was completed exactly as written up until this point. The original lesson has a short discussion of about 5 minutes where the students are supposed to see that the farther apart the magnets are, the weaker the force between them. The teacher, however, found that the students were confused by the data and only 1 or 2 seemed to get that there was a relationship. Later, we found out that because it was a nonlinear relationship, the kids did not think that there was a relationship at all. We told the students that one way we can make sense of the things that we observe is to think about what caused those things to happen. We call this a cause and effect relationship when an action causes something else to happen. For example, if I kick a ball, it would roll down the field. I introduced the sentence frame blank, so blank, as a way to express this relationship. And I started with an example they would all be familiar with. I kicked the ball so, and the kids did a choral response with the effect. I then went over to the light switch and said, I turned off the lights as I did so, and the kids answered in choral effect that it went dark. We then started the science talk where we asked the students to think about cause and effect relationships in terms of what they had observed or did in the breaking the force activity. It worked well to use a T-chart in this instance to record their responses as a cause and effect relationship. Sometimes students would start with what happened or what they observed, and then I could prompt them to say what had they done before they observed that effect. Also, the students brought in evidence from prior lessons, for example, magnets connecting when they are close and a magnet falling down to the ground when it was far away from the top magnet. Logistically, it worked well to use different colors for each cause and effect relationship so that the kids could easily track each cause and effect connection. We discovered during this talk that because the relationship was not linear, the students found it confusing. They saw a big effect at the beginning of the experiment. It took 5 or 4 washers difference between each banana chip spacer, and that big effect tapered off after the magnets were a certain distance apart, where only 1 less washer or even no difference in the washers were needed to break the force. But when we referred back to our cause and effect chart, there was consensus that there still was a relationship, even if it was strongest when the magnets were closest and tapered off as the magnets became far apart. Whenever there's a variable that has a direct effect on a system, I think it's really a productive place to bring in this cause and effect relationship. I have found that you can prompt the kids to see if they can use that word so in their writing or speaking. And if they're not getting it after that, you can do a T-chart together to help them see that relationship a little bit more explicitly. What I have found from trying out this subtle shift was that using the cross-cutting concept of cause and effect relationships is a really useful tool for the practice of analyzing data. Once you've introduced this mini lesson, you can refer back to the SO sentence scaffold and the T-chart to cue kids into this kind of thinking. Well, the students, after this part of the lesson, were able to see that there was a relationship between the distance between 2 magnets and their magnetic force. This is actually not the end of the story for this lesson. There were other questions that the students brought up that we addressed with the science practice of modeling, and I'll describe that shift in a separate video.